This, we'll understand about how do we evaluate confidence intervals for a population mean when the sample size is small and the population standard deviation is unknown. So the interval estimate of the population mean when the sample size is small with the confidence coefficient 1 minus alpha. Here this alpha is nothing but the level of significance. 1 minus alpha will give you the confidence level. So, and the confidence interval will be x bar plus or minus t times capital S divided by square root of n, where this x bar is sample mean, t is the t table value based on one-tailed test for a specific degrees of freedom. In this case, the degrees of freedom will be n minus 1. Capital S will be the sample standard deviation. When we evaluate the confidence intervals, it will be based on two-tailed values. But since the t-tables will have one-tailed values in our case, so we will take the confidence or the significance level, half of the significance level we'll consider to find out the table value of t. So now to understand this, let us go with an example. A question number 1. A random sample of size 7, which means our n value is 7, small n value is 7. From a normal population as a mean sample mean, which is x bar 980, with a standard deviation, which means S is 4.42, and this 1 minus of alpha is given as 95%, which means 0.95, which means our alpha will be 0.05. This is meant for a two-tailed test. So that means we need to consider for one-tailed to see the tables, we need to consider for one-tailed the alpha as 0.025. So now confidence interval will be x bar plus or minus t times S divided by square root of n. So here x bar is 980 plus or minus t value. N minus 1 will be the degrees of freedom, which means it is 7 minus 1. So you get 6 degrees of freedom. So we need to look into the tables for 6 degrees of freedom for a alpha of 0.025. We will get the table value as t value as 2.447. So here it will be 2.447 times 4.42 divided by root of 7. Therefore, the confidence interval will be, so let us calculate that, 2.447 into 4.42. 2.447 into 4.42. We get 10.980 plus or minus 10.81574 divided by root of 7. 7's square root. We get 2.6458. So if we divide this, we get 980 plus or minus 4.09. So that means the confidence interval will be, one is to subtract. We get 975.91 as the lower limit, and the upper limit will be 984.09. So this is the desired, we can conclude that the population mean should lie between these two values. Let us move on to a different type of question. The personnel department of an organization would like to estimate the family dental expenses of its employees to determine the feasibility of providing a dental insurance plan. A random sample of 10 employees reveals the following family dental expenses in thousands of rupees in the previous year: 11, 37, 25, 62, 51, 21, 18, 23, 32, and 20. Set up a 99% confidence interval of the average family dental expenses for the employees of this organization. So now we have created a table. Reason is that here they didn't give us directly the sample mean and sample standard deviation, which we need to find out. The second column is actually x minus x bar, and this is x minus x bar the whole square. So first of all, x bar we have to find. X bar is nothing but summation x divided by n. Here it is 320 divided by 10, so you get 32. So 11 minus 32, we get minus 21. This will be 5. 25 minus 32 minus 7. 62 minus 32, we get 30. And then 51 minus 32, we get 19. 21 minus 32, we get minus 11. 18 minus 32, we get minus 14. 43 minus 32, we get 11. 32 minus 32, it is 0. 22 minus 32, it is minus 12. So now we need to square each of these values. Negative 21, the square will become 441. This will be 25. This will be 49. This will be 900. 19 square is 361. 11 square is 121. 14 square is 196. This is 121. This is 0. This is 144. If we add up all this, we get 2358. Therefore, our S, which will be square root of summation x minus x bar, the square divided by n minus 1, which will be square root of 2358 divided by n minus 1 is 10 minus 1, which is 9. And if we evaluate that, we get the value as 16.2. So our n is 10 actually, which means our degrees of freedom, which will be n minus 1, becomes 10 minus 1, so it is 9. So based on this, now let us go to the confidence limits. Our confidence interval will be x bar plus or minus t times s divided by root of n. So here x bar, we calculated it as 32 plus or minus t table value. See here, t we need to look into our alpha will be 1% for a two-tailed test, which means it will be 0.5% for a one-tailed test. That is 0.005. So we need to look for t value for considering alpha as 0.005 and degrees of freedom as 9. We will get 3.25 as the t value approximately. So here it will be 3.25 times S value, we found it as 16.2 and root of 10. Let us calculate this. So 3.25 into 16.2, we get 52.65. Square root of 10 will be 3.2. If we calculate this, we get 32 plus or minus 17.55. Therefore, confidence limits will be, lower limit will be 14.45 and the upper limit will be the addition of these two. We get 49.55. So we can say that our mu will be lying between these two values.